Scenario B looks at what would happen had we had a regulatory compliant population in there, 150 people as they were supposed to have. And then we see that the evacuation is completed in 2 minutes 44 seconds. The average evacuation time is 1 minute 29, a cumulative wait time of 55 seconds, and so the average person wastes about 60% of their total evacuation time in congestion. This is to be compared with the 80% figure. And so you can see that it's a much better flow of people out of the structure. In fact, the entire population escaped without loss of life or serious injury. And this is just the simulations running with the regulatory compliant population. Congestion becomes severe, but it becomes severe much later in the sequence. So what we're saying is, had there been a regulatory compliant population in there, even with this fire, everyone would have managed to get out. This is looking at the history of the dosages that people received, the impact of heat and the impact of toxic gases. This is in case A, where we have the 450 people in there. And you can see that a lot of people are receiving high doses of heat, whereas in the regulatory compliant case, the dosages of heat that people have received are negligible. This is the toxic gas distribution of the survivors. And again, you can see in the case where we had the overpopulation, the toxic gas concentrations in the survivors reaches fairly high levels, whereas in the regulatory compliant case, it's quite low. Scenario C is the final case that we've looked at, and this looks at, well, okay, what if you had 400 people in there breaking the rules, but what if we had an additional staircase? What if there was another staircase made available in this building? Well, we find that the evacuation would have been completed in an average of 3 minutes 42 seconds, average evacuation time 1 minute 55, average cumulative wait time 1 minute 30 seconds, and so the ratio is 78%. So it's still very high. Even had we put in a second staircase in there, we still would have had, there still would have been a lot of queuing going on. However, 39 people would have had an FIH value of between 0.1 and 0.3, and so we could have expected that some of these people would have minor injuries resulting from burns. However, the entire population escaped without loss of life or serious injury. So had we had a second staircase, you still would have got a lot of congestion, you still would have had some injuries, but everyone would have managed to get out without dying or serious injuries. And this shows this evacuation sequence when we've put in an additional staircase. And we've put in the additional staircase on the far wall, the long wall. And the staircase is exactly the same design as the other staircases. Note some people are recommitting here. This is recommitment behavior. They're deciding to leave that queue and go to another exit queue for various reasons. You can still get a lot of congestion. So we've still got a lot of people in there trying to get out these stairs, but the total evacuation time is obviously reduced because we've got the two staircases. Again, if we look at if we compare the original scenario with the 400 people but only one staircase with 400 people but two staircases, again we see now these people are suffering from exposure to the radiative heat. The FIH is quite high for these cases, but it's under 0.3, whereas this is the case for the building where we had 400 people in one staircase and the FIH was approaching 1. This is showing you the toxic gas inhalation for the case where we had the second staircase. Again, it's not 0, but it's much, much lower than the situation where we had only one staircase. So to conclude this then, what we found, scenario A, which is trying to reproduce the incident, we're getting between 94 and 99 fatalities. In actual fact, we had 63 fatalities. We're predicting about 150 to 160 injuries, whereas in fact we had about 180 injuries in the actual incident. And what we can see here is that Building Exodus is successfully predicting the fatality order of magnitude. The location of the fatalities corresponds with what we've seen in the actual incident, and it's also giving us ballpark figures of the expected number of fatalities. What's the limitation of this process? Well, the evolution of the fire is not adequately represented within the evacuation simulation, due both to lack of experimental data and inaccuracies in the experiment, and also some of the modeling assumptions we had to make. Had we modeled this using a CFD model, we probably would have got some better results. Major causes, the major cause of fatalities in these simulations differed from that in the actual incident as a result of the modeling inaccuracies. It was found that the majority of people who actually died died from toxic gas inhalation, although they were also severely burned as well. But remember, we didn't have the full range of toxic gases in the simulation. Also, had the disco contained the legally permitted number of occupants, that's is scenario B, we predict that the evacuation is likely to have been completed without loss of life or serious injury. In addition, had an additional staircase been provided, even with the illegal population numbers, then the evacuation again was likely to have been completed with only minor injuries, but no fatalities or serious injuries. When using Building Exodus and other computational fire engineering tools, we conclude that a major loss of life in this incident is likely to result from congestion due to overcrowding of the hall, loss of one of the two means of escape, the rapidly developing fire conditions, and the lack of early alarm. Had the people been alarmed earlier, they would have managed to get out of the structure. We've done a number of other calculations. We've run something like 20 simulations in this particular case, a number of what-if scenarios, and this will be appearing in a journal paper, hopefully not too far away. Thank you.
Very much, Ed. Actually, I have a couple of quick questions about the fire, really. Was the door at the bottom of the stair where the fire was that door open or shut?
I'm not sure, but I think it was shut.
Because that would have a huge effect on the fire. It'd be nearer the Capron tunnel type situation if that would have been open.
Yeah. But in the experiment, they would have reproduced that.
Yeah, but so in the experiment, they built that rig, only it was just quarter scale, right?
Yeah,
So
it was an exact replica, except it was quarter scale. But they didn't burn. The fire was caused. There were a stack of chairs that were stored in the staircase, and it was an act of arson. Somebody set fire to that. Now, in the experiment, what they burnt were wood cribs, not the sort of foam that you'd have in chairs and so on.
So they were padded chairs. Yes, I mean, obviously, I would suggest that we could do some very nice work on the toxic gases by just looking at the fuel.
Yeah.
I mean, I could give you some great numbers. Perhaps we should talk about that afterwards. Questions?
I'm Koichi Yoshida, MLRI Japan. I think another risk control option in that case would be installation of the sprinkler system, so that your system can conduct something on a simulation on that case.
Yeah, we in SmartFire we can simulate sprinklers and water mist systems. So had we used SmartFire, for example, we could have simulated the fire and what would have happened if there was a sprinkler. So yeah, we could have taken that into account. But there wasn't a sprinkler in this building.
Jake Pauls, quick question. Was this actually used in a forensic retainer situation, or was it strictly hypothetical? You shake your head no. What kind of confidence would you, or what kind of changes would you have to make to get confidence enough to use it as an actual forensics assignment?
I think you can use it in its current state as a forensic tool, but you can't use it to give you concrete results. It's really giving you indicative indications. If we have very good data in terms of the initial conditions and boundary conditions, then I think we can improve the accuracy of our predictions.
Victor Shestopal, Australia. Tell me, please, how the fire was modeled in terms of heat release rate?
The fire in CFAS was modeled just using the CFAS capabilities, a combustion capability in CFAS, burning wood cribs, I believe. So we just modeled it in CFAS using the CFAS capabilities.
Yeah, what was the maximum heat release rate?
I can't remember. That's in the journal page. In fact, I think it's in the proceedings. It's in the proceedings.
Thank you. My name is Tsuji, Osaka University. My question or comment concern the interaction between the smoke or toxic gas motion and pedestrian motion.